All right, so this is question number 2005 from the AP Physics exam. It's just the regular form, and it's question number 1. This is a great question, and it follows along very well with what we've been doing in AP Physics 1, mainly because it has a graph. So here's our graph. We're going to look at this graph first and try to determine some things that we can use it for. So we have a position versus time graph. So remember, that's typically we've marked it X and we've put meters on this side. They've done it up top. That's not a big deal. They called it vertical position. We're going to call it X, which is the same thing. Remember, whenever you have a line, okay, so this is a very straight line going from 0 to about 8 seconds, that this would be constant velocity model. So we're going to put CVM. And they were a little bit tricky because you barely see the curve that's here, but there is a curve there. And from 8 to 10, that would be constant acceleration model. Once again, we have another straight line from about 10 to 18. That would be the constant velocity model again. Then we've got another curve. This curve is a little bit easier to see, and that curve runs from 18 to 20. So that would be the constant acceleration model. And then finally, we have a straight line from 20 to about 25, and that is the constant velocity model. So they want us, with this elevator that's going up and down, to go through and graph the velocity of the elevator as a function of time. If this is constant velocity model, what we need to do is we need to figure out what is the slope of this line. So probably the easiest thing to do would be able to take the points at the furthest point and subtract those from the point that's just in front. So let's go ahead and find the velocity here. We do know that velocity is equal to the change in x over the change in t, where x is position. And so we've got, it looks like 12 is our highest x minus, and this was really easy, 0, all over, and then we've got 8 minus 0. And 12 divided by 8 would give us about 1.5. So we know that from 0 to 8 seconds, we have a constant velocity of 1.5 meters per second. Let's do the same thing here, and we'll notice that our position stays the same. So from 10 to about 18, we have 0 meters per second. We're going to skip over the constant acceleration, and we'll look at the constant velocity model from 20 to 25. If we start at 20, notice that we have 12 again. That is our beginning velocity, and our ending velocity is 0. So this time we're going to go 0 minus 12. So that is our change in x. And we're going to divide that by our change in time. And our change in time would be 25 minus 20. So 25 minus 20. So we're going to end up with negative 12 on the top, and we end up with, on the bottom, we end up with 5. So when you actually have to do that, that's 12 divided by 5, and that gives you 2.4. So this is negative 2.4 meters per second. So far we've got everything that we need. And we can go ahead and graph the velocity of the elevator versus a function of time. So from 0 all the way up to 8 seconds, we see that we're 1.5 meters per second. So we're going to put a dot here to kind of signify where we start. Put another dot right here where our velocity is no longer the same, and we're going to just draw our line. And then from 8 to 10, there's a change in that velocity, and it goes down to 0 meters per second. So we're going to put a line here, and then what we can do is just kind of draw a line going, oops, I'm going to undo that a little bit, try to do this a little bit better. We're going to do a line really going from 8 to 10. And we can put a little bit of a curve there just to signify that we do have a change that's kind of gradual, but as long as you've got that line going from 8 to 10, you're set. We know that we follow then 0 meters per second from 10 to 18 seconds. So we're going to move that all the way over to 18 seconds. And then at that point, at the 18 seconds, we see that we change again and we go down to negative 2.4. So I'm going to try to find negative 2.4, at that 20-second mark. So I'd say it's probably about here. We need to try to connect, oops, did it again. Need to try to connect the dots again. This is why a ruler is so important. So we can move down to that negative 2.4, not yet 2.5. Not sure they'd count you off if you did 2.5, but you really want to try to get it so that it's just above that line. And so this graph would be worth 4 points. You get 1 point for having this very straight line at the 1.5. You'd get 1 point for having the connection between the 8 and the 10 to show the constant acceleration. Then they would do also a point, I think from what they had was another point here, and then you had another point here. So really, the 2 points where you're just kind of connecting, you don't have to do any figuring, that actually is just 1 point altogether. So that's where we end up with our 4. So these two areas where you've got the transition is 1 point. So there's 1, 2, 3, 4. They're just making sure that you understand the difference between where the line is straight, that has a slope, and then where it's curving is acceleration. So velocity, acceleration. I think that's what they were really looking for. So that is part A on that problem, and I think that's it for it.